Hello class, and welcome to our next lesson. We're going over section 2.2, prime factorization, and it is found on page 74. Alright, let's get started. Alright, this section can be very, very different. It involves a lot of different topics, or a lot of different types of math, so you need to pay close attention and make sure you take good notes. If you don't understand anything, once again, put a question mark by it so you'll remember what you don't understand and you can ask an intelligent question in class. Okay, let's get started. So one of the things you might be told to do in this section is you'll be told to find the LCM. So you might be told to find the LCM of some numbers, okay? So when you're told to find the LCM, first we need to ask yourself, what is the LCM? Some of you might remember, but it stands for the least common multiple. If you want to write that down, you can over to the side. You can write down least common multiple. So let's take a look at our A example. Our A example is going to be this. We are going to have 4, 6. You do need to separate that by a comma, and I don't want you to mistake that for a 46. It's a 4 and 6. So the question is, what is the least common multiple of 4 and 6? So, well, least, let's break down what this means. Least means smallest. Common, we're referring to what they both have in common. Multiple is a multiple of that number. Like if you were to multiply the number by 1, you multiply 4 by 1, you get 4. Multiply 4 by 2, you get 8. Multiply it by 3, you get 12. You get the point. So one way you can go about this is by making a list. So for 4, okay, and then make a list for 6. I'm just drawing arrows so I just know, okay, so my list is going to start over here. So for 4, I could have 4, 8, 12, 16, 20. And some people go, wait, are you just counting by 4s? Basically, yeah, that's what multiples are. So this next one has 6, 12, 18, 24. We're going to stop there. So the question is, what is the smallest number that they have in common on both their lists? 12. That's how the least common multiple works, okay? So let's say we had another example where you're told, let's do my B right here, and let's say you were given something like 10 and 6. You're getting something like 10 and 6, okay? Well, the LCM for this, if you go and make the list out, go ahead for yourself, and you can do that, but you would find that it's 30, okay? And let's do one more. If you were told to find the least common multiple for something like 24 and 8, well, the least common multiple for 24 and 8 is 24. You're like, wait, how's it 24? I thought 24 is right there. Well, 24 is a multiple of itself. Any of these numbers, they're multiples of themselves. See, look up here. I started with 4, because 4 times 1 is 4. 6 times 1 is 6. 24 times 1 is 24. And 8 times 3 is 24. So that is the smallest number that they have in common as a multiple, okay? Something else you might be asked to do is just to list the factors of a number. Now factors are kind of the opposite of multiples. They're more like the pieces that make up a number. So let's use 12 as an example. 12 is a great number. So if you're told to say list the, this will be our example 2. Example 2. List the factors. Let me make sure I spell the word factors right. Nope, almost didn't. Factors. There you go. List the factors. So we hold to list the factors of a number like 12. Okay? So we take 12, we list the factors. We're talking about all the numbers that you can multiply. So like what I like to do is I like to make my list. Like what numbers do I multiply to get 12? Well, I could multiply 1 and 12. Okay? I could multiply 2 and 6. I can multiply 3 and 4, and now we're done. You see, we've listed all the numbers. There's 6 numbers that you have. So I have 1, 12, 2, 6, 3, 4. You don't have to put the times symbol in between them. I just did that because it's like just showing what I'm multiplying by to get 12, okay? So if we had another one, let's say something like, what if we had something like 20? 20, okay, so what are some multiples of that? Well, I could have 1 and 20. I could have 2 and 10. I could have 4 and 5. And I think that's it. So you get the idea of multiples of there, okay? Some numbers, though, don't really have many multiples at all. So, for instance, let's take a look at this one. Let's say we have a C right here. And we have like 7. What's the multiples of 7? 1 and 7. That's it. And we'll discuss what that is in just a minute. All right, we have 2 more things to talk about. Now let's flip the page over. Example number 3. In this section, you will also, 3, gotta put the 3 there. Example number 3. You might be asked to determine whether a number is prime or composite. So let's go over what that is. So it's real easy. So you might be told, determine whether the number is prime. So is it prime or composite? I feel like this is some kind of game show, you know, like you do, is it prime or composite? Okay, so we have this right here. Now, question is, what do those words mean? Well, a prime number is kind of like 7, how we saw on the last page, how 7, the only factors of it were 1 and itself. That's a prime number. So if you think about this, a prime number is something like 2, 3, 5, 7, 11, 13, 23. Those are prime numbers right there, because only 1 and itself can go into it evenly. All right, so let's look. So if I was given a bunch of numbers, let's say this is my A, this is my B, this is my C, and I was told to tell whether these numbers are prime or composite. I got a 50, I got a 30, I got a 37, and I've got a 1 over here. Okay, so let's figure out what they are. Are there any numbers besides 1 and 50 that can go into 50? Well, yeah, that's even, so 2 can go into it. It ends with a 0, so a 5 or a 10 can go into it. There's probably more numbers than just that, to be honest. There are more numbers that could go into it. So the point is, it is not prime. It's not prime, it's composite. Whoops, I didn't put the P. Composite. Okay, so it's composite. 37. You can think all you want, but the only number that will go into 37 is 1 in itself. So this is a prime number. It needs nobody. It stands alone. Now 1. Some people think 1 is prime, but it is not. And you're thinking, is it composite? No, it's not. It is actually neither. 1 is a special case. It is neither prime nor composite. Because if you say 1 and itself, well, 1 is itself, so that it just doesn't, no. It just doesn't work. So 1 is not prime, it's not composite, it's neither. So that's what you would put there, okay? So those are some examples there. Last thing we're going to need to do, or last 2 things we're going to do in this section, probably the most tricky of them all, okay? One is called prime factorization, okay? So we have something called, for this example, number 4, we have something called prime factorization. And you should recognize that term, prime factorization. You should recognize it because that's the title of this lesson. You see, all the other things we went over were kind of leading up to this. They're easier than this. Prime factorization, once you kind of like, it's similar to when we listed all the factors of a number, but we're only going to list all the prime factors. We have to break it down. You guys have actually done this before. You guys did this when you made factor trees. Let's use a number that we've done before, like 12. Remember we listed out all the factors of 12? We're not going to do that. What we're going to do is we're going to break it down till we get just to all the prime numbers, okay? So work with me here. We're going to break it down. I have 2 and 6, okay? 2 is a prime number. Nothing else can go into it but itself and 1. But 6 can be broken down more to 2 and 3. Now I'm down to all my prime numbers. You can circle all your prime numbers. I have 2, 2, and 3, okay? So those are my prime numbers. What I'm now going to do is I'm going to write that using prime factorization. And you use exponents when you write like this. So how many 2's do I have? Well, I have 2 2's. So I'm going to put an exponent with a 2 right there. How many 3's do I have? I just have 1, so I don't bother. I just put the 1 3 right there, okay? So I have, this tells me I have 2 2's. You remember? This is like saying I have 2 times 2, whoops, 2 times 2 times 3. Well, if I multiply all these together, 2 times 2 is 4, 4 times 3 is 12, that equals that. That's what prime factorization does. It just helps us break it down into its prime components. So let's think about another number. Let's think about, what about something like 60? What if we had 60? We're told to find the prime factorization for 60. So we go and we make our factor tree. I break this down into 10 and 6, because 10 times 6 is 60. I break this down to 2 and 5. I break this down to 2 and 3. So what do I have? I have 2 2's, 1 5, 1 3. So right here I have 2 2's times 3 times 5. If you were to multiply all of this out, work it out, you would get 60. Okay? Let's look at another number. What if I had 64? Well, if you struggle with breaking it up the right way, you could break it down to 8 and 8, or you could say 2 and 32, 2 and 16, 2 and 8, and 2 and 4, and 2 and 2. I have 1, 2, 3, 4, 5, 6. I have 6 2's, so I put 2 to the 6th power. And if you wrote out 6 2's and multiplied them all together, you would get 64. That is how you'd write prime factorization. Okay, so last thing we're going to do is we're going to be told, in our last example, example number 5, we're going to be told to find the GCF. And this is like the LCM, but this is not least but greatest common factor. So what is the biggest piece that makes up two numbers? So as an example, let's take 12 and 18. One thing you might need to do is list the factors. There's multiple ways you can do this, but some people like to list out all the factors and find the biggest number they have in common. Now remember, we're listing the factors, not multiples, but factors. So 12, remember, there's 1, there's 2, there's 3, there's 4, there's 6, there's 12 that goes into it. 18 has 1 and 2 and 3 and 6 and 9 and 18. So you got those, and so what's the biggest number they have in common? They both have 2's in common, they both have 3's in common, but the biggest number they have in common is 6, okay? 6 is the biggest number that they share in common, all right? So the answer for this would be 6, okay? And that's one way you can do greatest common factor. We'll go over this more in class, and I'll even show you some easier ways to find greatest common factor. But do look over this. Most of this is review. It's stuff you guys have done before. If you don't remember this, you had better make an appointment with me so we can work on this a little bit more. But hopefully you do remember going over LCM and GCF and prime factorization, making your factor trees. So I think you went over that in like 5th grade some. So hope you remembered that. See you guys in class. Remember, write down any questions you might have.